Welcome to aminacademy.com. In astronomy, let us discuss about the impact of moon craters. The moon provides an important benchmark of understanding the history of our planetary system. Most solid worlds show the effect of impact, often expanding back to the era when a great deal of debris from our system's formation process was still present. On Earth, this long history has been erased by our active geology. On the Moon, in contrast, most of the impact history is preserved. If we can understand what has happened on the Moon, we may be able to apply this knowledge to other worlds. The Moon is especially interesting because it is not just any moon, but our moon, a nearby world that has shared the history of Earth for more than 4 billion years and preserved a record that for Earth has been destroyed for our active geology. Volcanic versus impact origin of craters. Until the middle of the 20th century, scientists did not generally recognize that lunar craters were the result of impact, since impact craters are extremely rare on the Earth. Geologists did not expect them to be the major feature of lunar geology. One of the first geologists to propose that lunar craters were the result of impact was Gro K. Gilbert, a scientist with the US Geological Survey. Creating the process, the cratering the process, let's consider how an impact at these high speeds produces a crater. When such a fast projectile strikes a planet, it penetrates 2 or 3 times its own diameter before stopping. During these few seconds, its energy of motion is transferred into a shock wave, which spreads through the target only and into the heat, which vaporizes most of the projectile and some of the surrounding target. An impact explosion of the sort described above leads to a characteristic kind of crater. The rim of the crater is turned up by the force of the explosion, so it rises above both the floor and the adjacent terrain. Surrounding the rim is an ejecta blanket, considering of material thrown out by the explosion. Observing the moon. The moon is one of the most beautiful sights in the sky, and it is only object close enough to reveal its topography, surface features such as mountain and valleys, without a visit from a spacecraft. A fairly small amateur telescope easily shows craters and mountains on the moon as small as few kilometers across. The flat lighting at full face does, however, amateur's brightness contrast of the moon, such as those between the Maria and Highlands. Now, using crater counts, what is that the technique? If a world has had little erosion or internal activity like the moon during the past 3 billion years, it is possible to us the number of impact craters on its surface to estimate the age of that surface. By age, here we mean the time since a major disturbance occurred on the surface, such as the volcanic eruption that produced the lunar marea. We cannot directly measure the rate at which the craters are being formed on Earth and the Moon, since the average interval between large crater forming impact is longer than the entire span of human history. Our best known example of such a large crater, meteor crater in Arizona, is about 50,000 years old. However, the cratering rate can be estimated from the number of craters on the lunar marea or calculated from the number of potential projectiles, that is, asteroids and comets, present in the solar system today. Both lines of reasoning lead to about the same estimations. For the moon, these calculations indicate that a crater 1 kilometer is in diameter should be produced about their 200,000 years. That means 1 kilometer of diameter of the crater is nearly about 200,000 years. Like that, 10-kilometer crater every few million years and 1 or 200 kilometer craters every billion years. If the cratering rate has stayed the same, we can figure out how long it must we have taken to make all the craters we see in the lunar media. Our calculations should that it would have taken several billion years. This result is similar to the age determined for the Maria from radioactive dating of returned samples. That means it is nearly 3.3 to 3.8 billion years old. Now we'll discuss further about the impact of moon craters. Moon craters formed by impact of asteroids, meteoroids, and comets offer invaluable insight into the history of the solar system and the moon's own evolution. They are remarkably well preserved due to the moon's lack of the significant atmosphere and other surface process, allowing scientists to study their structure, distribution, and age. Understanding the solar system's history. Moon craters serve as a record of the heavy bombardment period, a time when the solar system was heavily impacted by the space debris. By studying the distribution and age of the craters, scientists can infer the timing and intensity of the period as well as the rate of impact events throughout the solar system. Studying lunar surface evolution. The presence and morphology of craters help us understanding the moon surface properties and evolution. The lack of erosion and weathering allow scientists to study the original crater structure and the materials that were ejected and deposited during the impact events. The number of density of craters can also reveal information about the age different regions of the lunar surface. Understanding lunar interior properties. Some impact events, particularly large impacts, can create features, fractures, and melt layers, provides clues about the structure and composition of the lunar interior. The study of craters formation and their effects on the lunar surface can help constrain models of the moon's formation and evolution. Studying the impact process. Craters themselves are a product of impact processes and their characteristics, that is, shapes, size, and structure, provide information about the nature of the impact events themselves. Scientists can study how impact events create shock waves, melt and vaporize materials, and produce different types of craters, from simple bowl shaped craters to complex basins. Comparing with other planets and moons. By studying craters on the moon, scientists can compare them with craters on other planets and moons in the solar system. This comparative study helps us understanding how the different planetary bodies have been shaped by impact events and the unique characteristics of each. So far we discussed about the impact of craters on the moon. That is the impact of moon craters we have done. Please subscribe our YouTube channel.